back. Today we'll be doing section 4.5 on graphing rational functions. So the general procedure we're going to go through on each of them, we're going to find any holes and asymptotes. So how to find the hole: if we have f of x equals p of x over q of x, and each one is multiplied by some x minus c, and x equals, we'll do an ax plus c, could have a coefficient, x equals c over a, f of c over a is a hole. So you can even turn that into an ordered pair, c over a, f of c over a. Asymptotes, we spent a whole section on asymptotes, so you know how to find those. Find intercepts. Those are not any different than they've been in any other section. So then we sketch the holes, asymptotes, and intercepts. And then the rest with a graphing utility. Okay, so let's run through this with an example. So we'll take a look at f of x is x squared minus 1 over x squared plus x minus 2. So first we look for any asymptotes and holes. To look for holes, we do a little bit of factoring where we can. So the numerator was a difference of perfect squares. Denominator, we're looking for a pair of integers that'll multiply to a -2 and add to a +1, and that would be a +2 and a -1. So for x not equal to +1, f of x can then be said to be x plus 1 over x plus 2. So this is where we have a hole in the graph. And the f of 1, we have to put it into the simplified f of 1, not, of course, the original f of 1. So that would be at 1, 2/3. Vertical asymptote, use our let line to find it. Let x plus 2, our reduced denominator, equals 0, x equals -2. Make sure you have both sides of your equation. -2 is not a vertical asymptote. X equals -2 is a vertical asymptote. Then as far as horizontal and oblique, we simply use division. Since we have degree at the top less than or equal to the greater than or equal to degree at the bottom, we divide. If we have a smaller degree at the top, we just have y equals 0 as the horizontal asymptote. So x plus 1 inside, make sure you're using a division sign. Remember, that is not the same as a square root. Those are two different symbols. They mean two completely different things. Okay, once you're done multiplying, flip your signs. So f of x, again, for x not equal to 1, can be thought of as 1 plus negative 1 over x plus 2. So as x goes to infinity, this remainder term drops to 0, and we have y equals 1 left. That is a then horizontal asymptote. As far as intercepts, y-intercept, we set x equal to 0. So we're finding f of 0, which is 1/2. So 0, 1/2 is our y-intercept. X-intercepts happen when y is 0, so 0 is x plus 1 over x plus 2. Clear the fraction. 0 times anything is 0, so 0 is worth x plus 1. X equals negative 1. So we have an x-intercept at negative 1, 0. So lots of good information for us to plug in here. So we can start working on our sketch. Okay, so we have a hole at 1, 2/3. So 1 to the right, 2/3 up, open circle there. Vertical asymptote of x equals negative 2. So the asymptote is drawn with a dotted line, not a solid line. It's used to help us sketch the graph. It is not on the graph. The graph approaches this value. Horizontal asymptote of y equals 1. Same deal, it's an asymptote, so it is a dotted line, not a solid line. Intercepts, y-intercept at 0, 1/2. X-intercept at negative 1, 0. So we can tell we're approaching this asymptote this way, horizontal asymptote going that way. So then the question is, are we up here or down here with the rest of it? Since we don't touch the x-axis in multiple spots, we're somewhere up here, and at that point you're just using your calculator to do a quick rough sketch of the rest of it then. So you're just back in your y equals screen. So we fill in our remaining one, and we've confirmed with the graphing calculator that we are indeed, as expected, up here in Q3, not down, or in Q2 rather, not down here in Q3, since we didn't once again cross the x-axis. Let's try another one. Same rules of the road. We're looking for holes, asymptotes, intercepts, and to graph all that and then sketch. So this time we will have g of x is x cubed plus 4 times x squared minus x minus 12, all divided by x squared plus x minus 6. I don't know why I have 2g of x's there. Okay, so first we're looking to see if we can factor that numerator. So possible rational zeros, p over q. plus or minus 1, plus or minus 2, plus or minus 3. Since they're all over 1, I'm just looking at the factors of p. Plus or minus 4, plus or minus 6, plus or minus 12. So we have our 0 at x equals negative 3 of the numerator. So we can do our synthetic division. We don't have any missing terms. We have a third power, second power, first power constant. If we do have missing terms, remember to put a placeholder 0 to account for that fact. So we'll bring our first guy down, and then we're just playing the multiply and add game. So g of x, the numerator in factored form, if x equals negative 3 was a 0, x plus 3 was a factor. And then we have x squared plus x minus 4. Denominator, x plus 3 also happens to be a factor, lucky us. And x minus 2 would be our other factor. That way we're multiplying to a negative 6 and adding to a positive 1. So for x not equal to negative 3, we can call g of x x squared plus x minus 4 over x minus 2. So if we plug in our forbidden value of negative 3 for g, we can get an ordered pair out of that for the whole. So we have 9 minus 3 minus 4 upstairs, and negative 3 minus 2 downstairs. So 2 over negative 5, so negative 2/5. So negative 3, negative 2/5. So a little bit less than half on the y. Asymptotes. We have our reduced one. This one we don't have x minus 2 as a factor here. So it is fully reduced. So we'll use our let line on the reduced fraction. Let x minus 2 equal 0. So x equals 2 is a vertical asymptote. Horizontal and oblique. Check the degree. If we don't have the situation of smaller degree at the top, big degree at the bottom, where we can just jump right to y equals 0, we'll have to divide. So numerator inside, denominator outside. And again, make sure you're using a division sign, not a square root symbol. They do not mean the same thing. So x squared plus x minus 4 inside, and x minus 2 outside. So x by x will get me back to the x squared. X by negative 2 is negative 2x. Flip our signs. We have a 3x minus 4. I would multiply x by positive 3 to get to positive 3x. 3 by negative 2 is negative 6. And again, we're subtracting that quantity, so we flip both signs. So now we can also say that g of x is equal to x plus 3 plus 2 over x minus 2, again assuming that x is not equal to negative 3. As x goes to 0, x goes to infinity, the last term will go to 0. So y equals x plus 3 is an oblique asymptote for this graph. So it's not always a horizontal asymptote. We will occasionally have the oblique asymptote. Intercepts. Those you've been finding for quite some time already. So y-intercept only happens when x is 0, so we'll find g of 0. Yeah, we'll just shorten our work. We'll put in the reduced guy. So 0 squared plus 0 minus 4 over 0 minus 2. So negative 4 over negative 2. It's positive 2, so 0, negative 2 is our y-intercept. x-intercepts only happen when y is 0. So 0 is x squared plus x minus 4 over x minus 2. But as soon as we clear that fraction, the denominator goes away. And this one, completing a square would be doable. More of you probably would go for a quadratic formula since we have an odd in the middle, so we'll do it that way. So x equals -1 plus or minus square root of 1 squared is 1 minus 4 times 1 times -4 all over 2 by 1. So x is equal to -1 plus or minus square root of 17 all over 2. So we have a pair of x-intercepts, one at -1 plus root 17 all over 2, 0, one at -1 minus root 17 all over 2, comma 0. Okay, so we have our intercepts, we have our hole, we have our asymptotes. That's enough ammo to get this thing graphed. And I think I have enough blank space on the page. I'll go ahead and put that right here. We can fit it pretty nicely. Bit of an angle on it, that's okay. Okay, so we've got our hole for g of x. Our hole was at -3, -2/5. So left 1, 2, 3, and down a little bit less than half. So there's our open circle. There's a hole there. Vertical asymptote at x equals +2. Oblique asymptote of y equals x plus 3. So 1, 2, 3, and a slope of +1 on that. So our hole is very close to our nice pretty asymptote there. Okay, so we can get a pretty good picture of what's happening just from our intercepts as well. So our y-intercept was at 0, -2. Then our x-intercepts, again, we can go to the calculator for a rough approximation. So checking in the calculator, our x-intercepts, this one is approximately 1 point, let's say the plus is about 1.56. And the minus is about -2.56. So it's good to have the exacts as well. The rough estimates are just kind of useful little toys to have as well. So about 1.5, about -2.5, and that kind of fits in with what we're sort of expecting here. So our y-intercept, that's why that wasn't making, that last one was not making sense. I had it written as a +2, hit a little copy error there, 1, 2. Now this all fits nicely into one little picture here, so we're heading towards our asymptote this way. Since we don't cross the x-axis again, that means our other is up here. And again, you can confirm that with your graphing calculator that we have more going on up there. Okay, so maybe one more of these. Do an h of x this time. So we'll do 2 over x squared minus 9. So go ahead and pause it and see if you can run through all the steps with this one. Okay, welcome back. So first we look for any holes. To do that, we factor numerator and denominator as much as we can. This one I don't see any variable factors to be reduced, so there are no holes. So then next up, we look for any asymptotes. So the degree of the numerator is smaller than the degree of the denominator, so y equals 0 is an automatic horizontal asymptote. For the vertical one, we use our let line. We have a fully reduced fraction, so x equals -3 or x equals 3, so we have a pair of vertical asymptotes. No oblique asymptote this time, but we do have the horizontal asymptote. And as far as intercepts, y-intercept, we find h of 0. So 2 over 0 squared minus 9 is -2/9. So 0, -2/9. X-intercepts happen when y is 0, but we have 0 equals 2 over x plus 3 by x minus 3. We multiply both sides by the LCD. But as soon as I multiply something by 0, goodbye to that whole value. That will drop it to 0. So now we get the contradictory statement that 0 equals 2. That means we have no x-intercepts. So we never touch the x-axis for this one. No holes. We have all of our asymptotes arranged. So then we'll go ahead and make a sketch, and then some of this we'll have to fill in just with the help of the calculator. And here we go, get our little stamp going. Still a little crooked, that's okay. Okay, so drawing what we know for sure, no holes to draw, y equals 0. That is the x-axis. So the x-axis is a horizontal asymptote. We have two vertical asymptotes, one at x equals 3. One at x equals -3. Y-intercept at 0, -2/9. So that tells us in here we get close to our asymptotes, but we can't cross vertical asymptotes. So then the question is, where are the other two? And a little bit of work with the calculator reveals that they are up here. And really even a sign number argument would work well for that also. So our numerator was a +2. That's always going to be a positive. Something bigger than 3 squared is going to be bigger than 9. Bigger than 9 minus 9 is a positive. Positive over a positive stays positive. Same thing here. Bigger than 3 in absolute value, square it, it's going to be bigger than 9. This guy would be positive as well. So that one, technically we didn't really need the calculator, but we can confirm it with the calculator. All right, so some problems I would recommend trying out in 4 or 5. try out 1 to 6 all, 7 to 53 odd, 59, and 61. And I'll try to create a similar assignment on MyMathLab for the MyMathLab fans. If you have any questions, see me online. Otherwise, I'll see you again soon.